I'm back doing more word problems. These are real world experience problems where we're doing linear equations and we're kind of coming up with a whole bunch of information from a piece of data, whatever it may be. So I've done a few of these. So some have graphs, some have tables, some have just a scenario. So this will kind of compile all those pieces together into one big document on one page. So we have this information. We have Appletown, which is a town. And we see that the x coordinates are all referring to years since 1990. And you can see that each line is worth 3 on this particular graph. And then we have our population here, starts at 0, and then each line is worth 500 because the main grid lines or the major grid lines are by thousands. And so what we want to do in order to come up with an equation, real world meaning for this, figuring out what our variables are, coming up with a bunch of table values, we need some good points to work with. So I started off here with the y-intercept because that's always really important when we're doing the equation. So if I look at this graph, you can see that that dot that you see right here where it starts at, this is 2,000, this is 3,000. So that means that this is 2,500 right here. So if I look at this graph, I see only a couple of points that are nice points. And when I say nice points, they have to go through major like grid lines so that you can see them, because it's really hard when you have middle of lines and like 3/4 of a line, like you don't know what the actual numbers are. So you can see that this first point that I put after the initial point is at 12 years, and then you can see that it's at 4,000 as a population. So I use those 2 points in order to put my table values in. So you can see I have some table values here, the 0 and the 2,500, and then that point that I just did, 12 and 4,000. Now you can see when I'm counting and doing my slope, so I know what our y-intercept is, it's this number right here, 2,500. But in order for me to figure out my slope, I need to go from 2,500 up to 4,000, which is an increase of 1,500 people. And then from here, my run, this is starting at 0 and it's going all the way over here to 12, which is an increase of 12 years. So I just put the slope over here so you can see that 1,500 over 12, which means that there's 125 people per year that are extending the population. So now I have my slope. I have the y-intercept there at 2,500. I put that together in my equation, y equals 125x plus 2,500. So now I can continue on. I know what my pieces of information are. My real world meaning for this problem is that x is referring to the years since the population was started at 1990, and the y is the population. That's what the axis labels tell me on this graph. So I don't have to do any guessing. It's right here in front of my face. They're told to us. Now the 125 in this problem refers, because we want to make sure we know what the numbers mean, that's my change of population, and that's per year. So I'm just going to put that in there. And then the 2,500 is my starting population. So that is what we've got going on here. So that is that. That covers my corner for that. Now I'm going to write an equation, but I'm going to do that after. So again, I already started the equation. I made an equation, and now I'm just going to put some table values in. I have one more additional table value that's on this graph, which is 24 years past, and then that follows over here to 5,500. So I put that in there, and then I just kind of like looked at the pattern and said, okay, if I need 4 sets of data, you really can put whatever you want in here. But I just kind of decided to go, okay, well, this is plus 12. This is plus 12. So I just kept going with the pattern, plus 12. I had 3 points and I just kept going. So I just said, okay, this is plus 12, plus 12, plus 12. Then I look at this one, and this is going up each time. When I go from this to this, it's an increase of 1,500. So this was an increase of 1,500. So then I added 1,500, and that's how I got the 7,000 on this one. So this graph didn't have that set of numbers on it, but I just made it. You could really pick any numbers that fall on this graph, and you can find them for the equation right here by plugging any number in for x and then multiplying it by 125 and adding 2,500 to get your population for that particular year. Now, the last question that was asked in the bottom corner was write a question using your equation that you can't answer from the graph. Now, I picked one that was on the graph, although it's not clear to be able to see. So I then used the equation. So my question was, how many people are there in the population for Appletown in 3 years? So again, if I look at 3 years, it's really hard for me to tell that number. I don't really know exactly what that number is. So I just plugged it into the equation and came up with the answer, which was 2,875 people. But I could always have just used that 36 number, which is also not on the graph, but I used that in my table. So I could have used that number as well. And I could have said, what happens 36 years after I start this? So this is a pretty comprehensive problem, but it includes all parts of linear equations that would be for real world. If you want more questions like this, find them on my YouTube channel, You Want Algebra. Check them out under the real world scenarios section.